So in the previous class, in the lecture 1, so we have gone through the content delivery of this particular subject, and we have gone a detail about the syllabus. So in the today's class, so we're going to see the fundamental concept of this electricity. Fundamental concept of electricity. As an electrical engineer, we need to understand the basic electrical system. So this electrical system has different stages. Electrical system has different stages. So whenever you are transmitting this electrical energy from the source to that load, it has the different stages. The first stage, you can say, it is the production of electricity. Production of electricity. And then we'll go for the transmission of this electric energy. Transmission of this electrical energy. And utilization of this electrical energy. Utilization of this electrical energy. The last stage is the control of this electrical energy. Control of this electricity. So these are the 4 stages you can go through when you are going to study this electricity. So if you see this pictorial diagram of this particular system here, then you can represent this diagram, this various stages in pictorial diagram here. So this could be like this, or something like this, and so this is the 3 stages I have drawn here. This can be is like a source, acting like a source. This is the control, and this is load. Different loads we have, and the transmission can say here the transmission should be like this. You can say the transmission line, or you can say the transmission conductors are going like this. So these are the various stages. Source, so we have, and this is a conductor, and you can say this is the transmission line. Transmission line. So here sources are responsible to generate the electricity. So these can be the thermal power plants, hydropower plants, or you can go for the renewable energy resource, renewable energies, or this source can be a battery. This source can be a battery. And when it comes to here, the transmission line are nothing but the conductors here. You can say these are the conductors, and these are different materials can be acting as a conductors, aluminiums, copper, gold, and silvers. So different materials you can be used for this conductor for the transmission of your electricity from the source side to that load end. And loads can be to utilize this electrical energy, right? So this loads can be different loads we have: refrigerators, air conditioners, computers, and traction and electrical drives and heating equipments, and so many applications we have. And this is the particular stage is called this one, utilization of electrical energy, and this is that stage, first stage, the production of electrical energy. And this transmission part, this is the one another stage is called the transmission of electrical energy. When it comes to the control part, so in order to control your electricity, you need to go for different equipment for the control part. For understanding purpose, I can say this control is example is switch, a very simple switch which is we are using in our household application, on and off condition. So that is, you can say, the control part. If you see that simple electrical circuit diagram for this particular circuit, if you draw here, then this could be has some source. This has some source, and we have a switch here, switch, and this is, you can say, the lamp load, and this is the circuit, something like this. Source, and you have switch, and this is a lamp load. So this is the kind of electrical simple circuit, you can say, and this is called the wire, or you can say the conductor. Wire, or you can say it is a conductor. So this is how you can see the simple electrical circuit here, which is transmitting power from source to your load through these particular conductors. So this is what the very simple circuit. If you understand what is the things which is going to happening and the phenomenon, as electrical engineer, we need to understand. We need to analyze the electrical energy when it is transferring from this stage to this stage. It is transferring from source to the load. In between this phenomenon, what is the electrical energy is going to be converting from one form to the another form, and what would be the phenomenon which is happening inside. So those kinds of knowledge we will going to study as a electrical engineer. When it comes to the very basic fundamentals of this electrical system and electrical energy, the first we will start with the term. It is called the electric charge. Electric charge Q. So what is charge? In order to understand what is meant by this charge, if you recall your fundamental concept of your physics, in that physics we have studied about the atoms. Atoms has some nucleus and ions and electrons. So that concept, if you recall there, and in that, so consider a hydrogen atom. So I'm considering a hydrogen atom. This has nucleus, and this is the shell of this hydrogen atom. This is the hydrogen atom, and this has the one orbit around it, and the one electron is the free electron is moving or evolving through this particular nucleus, right? So this is the concept you might be studied during the when we are experiencing the physics subject. And similarly, if you write the same atom for the silicon, if you write, so this silicon has 3 orbits. So orbit 1, orbit 2, and maybe you can go, this is the 3 orbit it has around it, 3 shells it has. And the first cell, we have the two electrons. 2 electrons are free, are moving. In the second cell, have totally 8 electrons. You can say 8 electrons we have. In the last final orbit, you have some 4 electrons. So these are the free electrons which are evolving around this particular nucleus. So this is what the free electrons which are available on the your valence orbit in the case of atoms. So similarly, if you take some other substances like silver, if you take, the silver, this is Ag plus 1, and this is 1 electron is free available, and the copper, that is 2, and this has the 2 electrons are available, and the gold, this is, and these are the free electrons, and the aluminum. As we have, it has the 3 electrons, and so these are the some atoms. If you see what are the free electrons which are available in different materials, and you can see. So these materials are acting as a conductors. Generally we are used for our electrical energy transfer purpose, and these are the materials we have. And this silicon is a semiconductor device, conductor material, you can say. So this is what. Now we will see the concept of these positive electrons and negative electrons, and what are those kinds. So in order to understand this kind of concepts, so let us consider a X material. I'm naming it is some X material, and if you consider that X material that has some free electrons in it. So these are the some free electrons are available on this particular material or substance. Some free electrons are available, and if I remove this electron, and this particular electron from here, if I remove this electron from this particular substance, then it is going to form a blank spot here, and that blank spot is called hole, and this is also called a positive charge. Suppose if you are adding electron to this substance, then this is going to add electrons for this, and these electrons are called the negative charge. So this is what the concept, what is positive charge and what is the negative charge is available on this particular substance or this particular element. Then electrical charge can be defined as, what is the electrical charge? You can be defined as, this electrical charge can be defined as the excess of positive or negative charges available on the body or surface of the conductor, surface of the atom. So this is called that electrical charge. So whatever the free electrons we are left over on this particular atom, whatever the excess amount, if this substance has the negative electrons are excess amount, then this particular substance you can call it as the positive charge atom. And if the holes are excess or holes are more on this particular substance, then you can say the negative charge atom. So that is what. And this electrical charge can be measured in the unit of this particular charge is called the coulombs. Coulombs, you can say. Coulombs is the unit of this particular charges. Now we'll see how this electricity, when you are giving some battery or some electrical supply to this any conductor, how the current is flowing through this particular what do you call this particular conductors. So to understand that, let us consider. So this is my conductor, I'm assuming. And for this conductor, I am giving some supply system here. This is connected in a electrical circuit aspect, and I can say this is the cell, positive and negative as there. And as we know, this particular conductor has some free electrons on this atom. These are the free electrons. Free electrons are available. So these are the electrons, and this is my switch is there here. Assume that the switch is there, and whenever the switch is closed here, then when the switch is closed, this electron start moving towards this positive terminal of this particular cell. So this could be the direction of these electrons. This is the direction of these electrons. These electrons, negative electrons, started in this direction, and which are going towards this positive terminal of this particular cell. And this, whenever these electrons are moving from, the electrons are moving from a negative terminal to the positive terminal, negative terminal to positive terminal, but the current direction is in this direction. My current direction is going in this direction, and I can say the current is going from positive to a negative. So this is what the constitution of the current in this direction. So here I can define that one term. It is called the current I. So what is mean by this current? How will you define it? It is nothing but the flow of the movement of charges, the movement or the flow of charge constitute the current. Or I can say the flow of charge of the flow of charge for unit time. The flow of charge for unit time, I is equal to the flow of charge for a unit time t. So I can write something like this is the coulombs unit, and this is the time is in seconds, and this can be written as amperes. The another definition of this current, you can say the rate of change of electrons, and I is equal to dq by dt, or you can say it is also in amperes. That the different definition you can need to understand here, the rate of change. And this expression you can get the steady state current expression, and this expression you can say the time varying current, you can say time varying current. So after this this current, you need to understand one more concept here. It is called the DC current DC current and the AC current. What is meant by this DC current and this AC current? So if the current is constant irrespective of the time, then it is called the DC current. If we draw this diagram something like this, the current versus the time here. So irrespective of the time value, as the time varies, irrespective of that, my current is always constant. So assume this is a constant line, irrespective of the, as my time is increasing, but still my current is maintaining some voltage X here, isn't it? For every point of my time, my current is maintaining the constant value. So irrespective of the time, my current is constant. So that is called the DC current. When it comes to that AC current here, so this current is varies with respect to time. This current varies with respect to time. In general, in case of your electricity, different waveforms we have. The fundamental electricity waveform we're going to consider, that is some sinusoidal waves. So this is what I'm considering here. This is time versus the current I. So as this time is varying in this direction, my current is also varying with respect to that. So this is what called that AC currents, and that concept here. The next term we need to understand is that electromotive force and potential difference. So to understand this, let us consider a very basic network here, which has been connected with some load, something like this, and I can say this is the source and this is my load here, and this is my direction of current. So this is my direction of current I is going from this direction to here, it is giving, and here the source I can say the electromotive force EMF, and whereas the voltage across this particular load I can define it is the potential difference. So here EMF and potential difference are the similar quantities. If all the electrical energy is transferring from source to that load. My electrical energy from transferring from source to the load, then my EMF is equal to my potential difference. So that is the meaning of this statement. So EMF, if my total energy is transferring from EMF to that potential load, then my potential difference is equal to the EMF. Then what is the basic difference between your electromotive force and potential difference is, this electromotive force is always active. This electromotive force EMS always a active source. You can say a active. What is meant by this active? Because this EMF always tends to produce electric current in the circuit. Tends to produce electric current in the circuit. So that's why it is called, EMF is called an active source. And if you want to talk about what is the potential difference, So definition for potential difference, this can be either active element, can be active or passive. So that is depends on the application. But in this case, in this particular application, my potential difference is passive. In this particular application, my potential difference is passive because it is absorbs it is not able to produce electricity, but it is absorbs the electricity. It is absorbs the current. Absorbs the current. In some cases, this potential difference also can be act as a active source. Now we'll see what is exactly the definition for this particular potential difference. So we'll write what is the potential difference here. The definition for potential difference: the difference of potential between 2 points of conducting wire. So that is the definition. If you consider, this is my conducting wire. Then if you see here, I'm considering at this particular point 1, and somewhere here this point 2. So there is some potential is there. Here some potential is there, and here some potential is there. And what is the difference between these two? The difference between these two is called the potential difference of this particular wire. So this is how you can define the potential difference, and the units for this particular EMF and potential difference can be measured in volts. The units for this particular measurements can be measured in volts. Now we will see what is the definition of electric potential. In the previous concept, we have seen the electromotive force and potential difference, and we will now see the definition of electric potential. So it can be defined as the work done to bring a charge from infinite to the any point against electric field. So this is the definition of this particular electric potential. So to understand this, let us consider some different electric charges we have. So assume these are the electrical charges we have on any particular material or conductor, and due to these electrical charges, it is going to create an electric field around it. So this is the electric field I have, and these are the different electrical charges available, and assume this electrical charge I can write the different points: point 1, point 2, point 3, point 4, and so on up to n points we have. These are the electrical charges we have. So my definition is bringing a charge from infinite to any point against this electric field. So this is my infinite space. infinite space here somewhere. I have some charge Q is there here. I try to bring this charge Q, this is I assume it's a negative charge. I try to bring this charge to any point. Let us, I'm bringing this particular charge to point 1. I'm bringing this charge to a point 1 in the against of this electric field. In the against of this electric field, then how much work I done to bring this charge from infinite position to my point P1 in the against of this electrical field, that is called the electric potential at this particular point. And this can be defined as, this electric potential can be defined as the work done per charge, that is work done W by Q, it's joules by coulombs, and this can be written as volts. So this also can be it can be named as voltage, isn't it? This electrical potential it can be named as voltage, and voltage V, we can write W by Q, and voltage V, the rate of change of work done on this particular charge. So this is steady state voltage, and this is, you can say that, time varying voltage. So these are the concept we need to understand here. Now we'll go for the another terminology is called electric power. And can be as P, and units are watts, watt. So to understand this electrical power is a very simple concept. Let us consider a resistor which has been connected to some source here. The voltage, you can say, and whenever you are connecting this resistance R in the AB terminal, and we are giving some potential to this particular resistance, and it's going to constitute some current I. When this current is flowing through this particular resistance, so this will dissipate the power, dissipate the electrical energy, or dissipate the power. And assume T is the time. T is the time during which the energy dissipated. So energy is dissipated. Then my electrical power can be defined as, the power, the rate of energy consumption. The rate of energy consumption is called my power. So that is, I can write my P by the rate of energy consumption for a given unit time. Or I can write energy transfer into electrical circuit, the rate of energy transformed into an electric circuit, and this can be written as this power. This is V into I, or sometimes you can write V square I, V square by R. This is the unit is watt. So this is the basic definition of this particular electrical power. Now comes to the another the last concept in this today's session, that is the electric energy. Electric energy. Electric energy. See, so the definition of this electric energy is the ability to perform a work done. Ability to perform a work is called energy. So how much the work we have been done in order to transfer this particular energy from voltage to some source to this particular resistance R. This how much work has been done, that is called that electrical work, or you can say electrical energy. And this is can be you can define electrical energy, total amount of electric work done. The total amount of electric work done. And the expression for this is nothing but your power is multiplied with the time, and you can write it is a watt hour. Watt hour is the units for this electrical energy. So these are the very basic terminologies we are going through this session, and I think you have understood all the basic terminologies: what is charge, current, potential, electric power, and electrical energy. In the next class, we will be going to deal with some basic electrical elements and Ohm's law.